Okay, so let's look at the second example here. Again, you want to be thinking about looking at the patterns and seeing if that reminds you of any of the Taylor series. You can go back to the table, I'll do that in a minute, to see if this rings a bell. But for this one, we don't have factorials in the denominator. So that's going to rule out a lot of different Maclaurin series. It's not sine, it's not cosine, it's not e to the x. All of those have factorials in them. So that's one way you can rule things out. Also, the series is alternating, right? So that's, again, more information. And then the numerator is always 1. So that's also going to help us with getting, for example, the x value in a minute. So you might have already figured out which series we're going to use for this one. I'll just pull up the table once again. Let's look at 1, 2, 3, 4, 5, 6. Let's look at the ln of x plus 1 series, right? So that's number 6 down from the top. So that's x minus x squared over 2 plus x squared over 3, so on and so forth. So that is the ln of 1 plus x, or x plus 1, which is x minus x squared over 2, x squared over 3 minus dot, dot, dot. And now if we compare that series, right, to the series that we have, let's look at, first of all, if it might make sense. The denominators here are just increasing whole numbers, if you will, 1, 2, 3, 4. This would be x to the 4th over 4. And then it's an alternating series. So increasing whole number denominators, alternating series, check. So it looks like this one might fit. And then what would be the x value? Well, just for example, looking at the 1/2 term, x squared over 2. So it looks like, right, x is going to be 1. Let's try that. How about ln of 1 plus 1? That would be 1 minus 1 squared over 2 plus 1 cubed over 3 minus 1 to the 4th over 4 plus dot, dot, dot. So 1 minus 1/2 plus 1/3 minus 1/4 plus dot, dot, dot. That is reproducing the series that we had. So we do think that this series equals ln of 1 plus 1, which is ln of 2. Again, we should go back and do what we did earlier. We should verify, right? This is ln of 1 plus x at x equals 1. Question, does ln of 1 plus x converge? Does the Maclaurin series for ln of 1 plus x converge to ln of 2 at x equals 1? Well, let's go back to the table, right? This is where, again, not just knowing the Maclaurin series, but its interval of convergence. If you look all the way to the right here in the ln of x plus 1 series, the 6 series from down from the top, you see that the convergence is from -1 to 1, including 1. So we just barely eked it out here. So this does, in fact, give us convergence. And in fact, this infinite series then we can say equals ln of 2.